Welding. It's an absolutely incredible skill, right? You're literally fusing metal together with intense heat and light, building the very world around us. It's all about raw power and precision. But, with that power comes a huge responsibility to understand the risks, especially the ones you can't always see. So let's get into what's really going on inside that plume of smoke.
Every single time you strike that arc, you're creating more than just a solid joint. A plume of fume is released. And that leads us to the most critical question we have to ask ourselves. In that flash of the arc, what are you actually breathing in?
To get to the bottom of that, here's how we're going to break it all down. First, we'll pinpoint those invisible dangers lurking in the fumes. Then, we'll walk through a pro-level strategy for dealing with them. It's called the hierarchy of controls. From there, we'll check out the tech designed to clear the air, and we'll finish up with your final line of defense, your personal shield.
All right. First up, the invisible dangers. A burn from spatter is immediate, it's obvious, but the real long-term threat, the one you can't always see, is in the air you're breathing. The damage from these fumes can be super gradual, but believe me, it's every bit as serious.
So that cloud rising up from the weld pool, it's not just smoke. No way. It's a really complex cocktail of stuff: metallic oxides, silicates, and fluorides. Just picture microscopic particles of metal that were vaporized by that insane heat, and now they're just floating around right in your breathing zone. And these dangers are very, very specific. Take hexavalent chromium from stainless steel. Its safe limit is incredibly low. We're talking the equivalent of a few grains of sand in a whole swimming pool. Then you've got manganese, which is in most fumes, and it has a ceiling limit. That means you can't be exposed to a high concentration of it, not even for a second. These rules exist for one simple reason: this stuff is seriously hazardous to your health.
So here's the bottom line. A PL, or Permissible Exposure Limit, isn't just some friendly suggestion. It's an enforceable OSHA regulation. It defines the absolute maximum exposure you're allowed. Going over that line isn't just a compliance issue, it's flat out unsafe. So how do you stay on the right side of that line? Well, that's where a smarter approach to safety comes in.
And that brings us to something called the hierarchy of controls. Now, this isn't just some random list of safety tips. It's a professional system, a framework for getting rid of hazards, and it starts with the most effective solutions first.
So here's how it works. From the most effective down to the least. You always start at the top with substitution. Can you change the process or materials to make fewer fumes in the first place? If you can't, then you move to engineering controls to physically remove the hazard. After that, it's about work practices, like how you position your head and body. And only at the very, very end, as the absolute last line of defense, is PPE. The key takeaway here is to always try and solve the problem as high up this chain as you possibly can. So let's zero in on the most powerful step in that whole hierarchy: clearing the air. This is all about engineering the danger away before it can ever get close to the welder.
And this right here, this illustrates the power of technology perfectly. On the left, you see a traditional fume extractor hood. It has a pretty small capture zone, maybe 18 inches. That means the welder has to keep stopping and moving it around. But now, look at the right. Newer tech creates this massive capture zone, up to 5 feet wide. This means less repositioning, more time actually welding, and way, way more effective fume removal. It's a total game changer.
This quote really just nails it. A bigger capture zone isn't just a nice to have. It directly makes the work environment cleaner, and, this is crucial, it helps a shop stay compliant with those PELs we were just talking about. So, better tech means better safety and, frankly, easier compliance.
So how do you get even closer to the source of the fumes? Well, you use a fume extraction MIG gun. The concept is brilliant. It's like having a tiny, super powerful vacuum cleaner built right into the nozzle. It just sucks the fumes away the very instant they're created. That's what we call source capture, and it is the gold standard for engineering controls.
But what if you're not at a fixed station? For maintenance or repair jobs or fabrication work all over the shop, mobile solutions like this are perfect. They give you powerful, flexible extraction that you can wheel right up to wherever the work is. This makes sure you're protected no matter where you are in the facility. And then for the really big operations, you have centralized systems. You can think of this as the HVAC system for welding fumes. It's a massive, facility-wide solution built for manufacturing lines and robotic welding cells. It ensures the air quality for the entire building is managed effectively.
So, after all the engineering controls are set up and running, we finally get to the last step in the hierarchy, the final line of defense, your personal shield. This is that non-negotiable layer of protection that is entirely on you, the operator. Look at this number, 70%. Just let that sink in for a second. That's the percentage of employees with hand injuries who later said they were not wearing gloves when it happened. That's a shocking statistic, and it proves just how vital this basic piece of PPE really is.
And this is the answer. The right gloves, they're not optional. OSHA requires flame-resistant gloves to protect you from heat, from spatter, and from electric shock. Your hands are your most direct connection to the work, so protecting them has to be priority number one.
Okay, let's get back to the air we're breathing. Look, even the best engineering controls might not capture 100% of the fumes. And in any situation where the fume concentration just can't be brought below those legal limits, respiratory protection isn't just a good idea, it is absolutely essential.
And you've got options here. On one hand, a simple half-mask respirator gives you great protection and fits under most welding helmets. But for the absolute highest level of safety and comfort, especially if you're welding all day, you have PAPR systems. They use a powered blower to feed you a constant stream of fresh, filtered air right inside your helmet. The right choice really just depends on the specific hazard and fume levels you're dealing with. And hey, let's not forget the helmet itself. A modern auto-darkening lens does so much more than just shield your eyes from the bright arc. Advanced optics actually filter the light to give you a clearer, more natural view of the weld pool. And this isn't just about comfort. It directly improves your precision, it improves the quality of your welds, and it really cuts down on eye fatigue.
So, we end with this one question. After looking at all these layers, from changing the process itself to engineering the fumes away, all the way down to your own personal shield, is your safety system truly complete? It's a question every single welder and every shop needs to ask, because a complete system, that's the only way to make sure you can keep on building our world safely.